Welcome to ClickMyProject.com.
This is our title, Verifiable Machine Learning Enabling Integrity Assurances and Fair Payments for Machine Learning as a Service. This is our abstract. Machine Learning as a Service allows clients with limited resources to outsource their expensive machine learning tasks to powerful servers. Despite the huge benefits, current machine learning as a service solutions still lack strong assurances on one is service correctness, example, whether the machine learning as a service works as expected. Second one is trustworthy accounting, example, whether the bill for machine learning as a service resource consumptions is correctly accounted. Third one is fair payment, whether a client gets the entire machine learning as a service result before making the payment. Without these assurances, unfaithful services providers can return improperly executed machine learning task results or partially trained machine learning models while asking for overclaimed rewards. Moreover, it is hard to argue for wide adoption of machine learning as a service to both the client and the service provider, especially in the open market without a trusted third party. This is our flow diagram. First, we start our project, then select our dataset. Dataset is banknote authentication using our base paper, and then view our dataset, and then data preprocessing. Data preprocessing is data cleaning method to be used. Data cleaning is a null values to remove and then empty values to remove our dataset, and then feature selection. Feature selection is to using our train data and then test data to split our dataset, and then classification is existing algorithm and proposed algorithm to be used our base paper. Existing algorithm is logistic regression and decision tree and then support vector machine. Proposed algorithm is ANN means artificial neural network. Logistic regression is a binary output to generating, example yes or no option, and then decision tree, it will generating tree concept, and then SVM support vector machine classifying a data using hyperplane, and then proposed data is ANN artificial neural network. This is a deep learning method. Input data and then output data, checking the generating outputs for accuracy and then precision tree called F1 score. Then final result generation to be displaying the accuracy each one algorithm, existing algorithm and proposed algorithm. And then finally graph generating. Graph generating is a overall accuracy comparison, existing algorithm and proposed algorithm. Logistic regression algorithm, decision tree, support vector machine is a existing algorithm, overall accuracy, and then ANN artificial neural network algorithm using accuracy to compare these algorithms. This is our output. First, I am going to import our dataset. Dataset name is banknote authentication, and then read dataset, and then view dataset. This is our dataset, and then splitting our dataset. Then check null values false. Then splitting our dataset, independent dataset and then dependent dataset. Independent dataset are 80%, and then balance 20% are dependent dataset. This is a dependent dataset. This is a independent dataset. And then I am going to using algorithm. In this paper, existing three existing algorithm used for our paper. One is logistic regression, another one is decision tree, and then SVM. Logistic regression accuracy is 98.54, and then confusion matrix. Then second algorithm is decision tree. Accuracy is 97.95. This is our confusion matrix for decision tree. And then final SVM, support vector machine. Accuracy is 98.54. This is confusion matrix. And then proposed algorithm is deep learning algorithm, ANN for artificial neural network. Accuracy is 99.319. This is confusion matrix.